So hello and welcome to our session on investigating the significance of spatial distributions with ArcGIS Pro. We'll be walking you through how you can apply the data engineering and spatial statistics tools available in ArcGIS Pro to a real-world example. We'll then take a look at how users can access different data science libraries using R and Python. Whenever we look at a map, we inherently start by turning that map into information, by identifying patterns, assessing trends, and making decisions simply by using our brains. We naturally organize and cluster what we see to help us make better sense of it, actively turning data into information. The spatial statistics tools in ArcGIS work in the same manner. We can provide data, ask questions of it, and begin to understand the spatial processes and distributions that might be present. So let's begin by framing our problem. In April this year, it was reported that every single London borough had breached WHO guidelines for the toxic pollutant nitrogen dioxide. As a society, we're becoming increasingly aware of the negative impact poor air quality has on our health, with those living in polluted areas having a greater chance of developing chronic illnesses over their lifetime. It's no wonder then why London squirrels are swapping the big smoke in search of leafy suburbia. However, there's evidence that the strategies to tackle air pollution in London are working. London's low emission zones have reduced pollution levels by more than a quarter, and an estimated 5 million more people will be breathing cleaner air as a result of August's ultra-low emission zone expansion across all London boroughs. So how does spatial statistics fit in? Well, Adriana and I wanted to investigate the link between air pollution and preventable mortalities in more detail. We understand that this topic might be sensitive for some, but we note the role and importance that data has in providing actionable evidence in the health sector and providing an opportunity for informing strategic interventions. The data engineering tools in ArcGIS are a common first step when approaching any analysis workflow. And I'll now jump over to ArcGIS Pro, where I'll show you some of the tools that can help you prepare your data before analysis. So on screen now, we have some data for London. And this is the under 75 mortality rate from diseases considered preventable that are associated with respiratory problems. This data has been accessed through Esri UK's National Data Service, which is a one-stop source of national statistics for England. As this data was available nationally, I've gone ahead and clipped it to the Greater London area. So first off, let's have a look at the tools that can help us clean our data. So if I expand our data engineering window here, we can see that this data has lots of fields in it. And this kind of shows you the wealth of data that's accessible from this data set. But I don't need all of this data for my analysis. So I can head to our data engineering ribbon at the top here, go to clean, go to delete field, and I can start to modify that input table by simply clicking on any of my fields and pressing OK to delete them. Once we've got better prepared data, we can start exploring it in new ways. The data engineering tools allow us to quickly look at visualizations for data by simply clicking the Update Symbology tool. And as we can see, the map is now updated with a clear symbology. And with one click, I'm able to start identifying those patterns and understand where might be worse affected in terms of preventable mortalities. As well as that, the data engineering tools provide options for descriptive statistics. And I can have a look at calculating basic measures of central tendency. I can drag across lots of fields and simply press calculate. This allows me to then look at the mean, maximum, mode, quartiles, for example, as well as providing nice chart previews. And these allow us to have a look at the spread of our data. It means that quite quickly we can start to look at whether we have outliers or there are extreme values that need to be corrected before we go forward with our analysis. Finally, I want to show you how you can augment your data using ArcGIS Pro. One of the handy tools that has been included is the Enrich tool. And this allows us to add in data for different variables, including categories on population, income, age, and many more. Using this tool, I could add in data for the areas specified, and that would allow me to look at the population breakdown for these areas, for example. Now that we've taken a look at our data engineering tools, I want to hand over to Adriana, who will be looking further at the geostatistical and spatial statistical toolboxes available to users.
Thank you, Ollie. So I'm going to explore the relationship between air pollution and the mortality rates from respiratory diseases considered preventable. I have loaded in data from DEFRA UK Air, their open source data archive, and I've loaded it into Pro. This data shows the air pollutant PM10. PM10 is particulate matter that is 10 microns or below in size. So once it's inhaled, it can affect the heart and lungs. So it's a good indicator of air pollution. This data is shown on average in 2021 in the Greater London Authority area. But as we can see, 3 of our authorities have missing data. So to begin, we're going to complete the data set so that it's ready for analysis. And I'm going to do so by using the GeoStatistical Analyst toolbox. This toolbox requires a GeoStatistical Analyst license, and the tools allow you to analyze data, predict values at unmeasured locations, identify new sampling sites, and perform geostatistical simulation and sensitivity analysis. But today, I'll be using the inverse distance-weighted IDW tool, situated in the interpolation toolbox. This tool will allow me to fill in the missing values for my air pollution data by using data from the neighboring authorities around the authorities that have missing data. Given that my dataset is quite small, I'm merely going to use the interpolation tools to allow me to get a best guess at these missing values. The geostatistical analyst tools can be quite technical, so when understanding how to use them, I like to use the tool reference feature, located in the top right-hand corner. And this allows me to view a few web pages that provide more information about what I can expect from the tool, and even what the parameters and outputs mean. So with this tool, I require an input feature of point data. So I've generated point data for the center of each of my authorities containing the necessary data. And the Z value that I'll be using is PM10, as this is what I would like for the tool to be weighted against. I'm just going to ensure that my environments now are set to the boundaries of the London authorities, as this is where I want my tool to be appended to. As we can see, this interpolated surface raster now shows a data set of air pollution values for the Greater London Authority areas. And if we look at our missing authorities that previously did not have data in them, we can now see a predicted value for the authorities based on how the tool has been run. I can now take this data back down to the polygon level, and as we can see, in just a few steps, we've managed to complete our data set so that it's ready for further analysis. I'm now going to explore the statistical relationship between the air pollution data and mortality rates from preventable respiratory diseases. And specifically, I'm going to explore if there is a spatial statistics in areas of higher mortality rates where there is higher air pollution. We're going to be looking at features in context to their surrounding neighborhoods because we expect things closer to each other to have similar characteristics. I'm sure most of you here have conducted a hotspot analysis in the past to identify areas of similarities, maybe. Something I've always been intrigued by, though, is comparing multiple hotspots, and I haven't yet been able to do this. Thanks to ArcGIS Pro 3.1, we now have a tool located in the Spatial Statistics toolbox that allows us to do exactly this. The Hotspot Analysis Comparison tool allows us to input 2 hotspots and run an analysis to identify their similarity and association. So I've already generated 2 hotspots for my air pollution data and the mortality data, which Ollie was previously looking at. So with a hotspot, we're able to identify areas of statistical significance. For example, with the air pollution data, if we have an authority where air pollution levels are significantly higher in relation to the surrounding neighbourhoods, it's considered a hotspot. Hotspots can be evaluated at 3 different significance levels: 90, 95, and 99% confidence. The same process is then used to identify areas of cold spots, where the statistics are significantly lower, and anything in between is marked as not significant. So I've generated these hotspots for my air pollution data and for my health indicator data for mortality rates. So I'm going to input them into the tool. Now, the number of neighbours refers to the number of neighbours around each feature that will be used for the distance weighting. When learning about how to use this tool, I wanted to gain more information about this input feature. So I've referenced the tool reference feature to learn more about it. And it told me that with a smaller data set, I might want to reduce the number of neighbours. So I'm going to reduce it down to 5 and run the tool accordingly. Here are the output results that we are shown. Each significance level combination displays custom symbology to identify a feature where one input hotspot was a statistically significant hotspot and the other was a statistically significant cold spot. So when we're looking at that relationship between the air pollution and mortality rates, we're really interested in this hot-to-hot relationship, as we can see in these 3 authorities, as this indicates where in both input data sets that we've loaded into this tool, there was a hotspot at both of these locations. For example, we can see exactly this at Tower Hamlets. So when we're looking at the custom symbology in this tool, the 90, 95, and 99% significance levels are not distinguished in order to reduce the number of combinations. Rather, we look at the symbology through hot to cold to not significant for ease of interpretation. But if you would like to understand your data and look at these significance level pairs, you can do so by using the charts that are automatically generated when you run the tool. So we're produced with a heat chart and a customized bar chart when you run the tool, and these show the significance level pairs. And it displays the same information as the tables in the messages. And it's displayed through colors. The colors are displayed through counts and percentages for ease of interpretation. If you then wanted to share these charts, for example, with colleagues, or you're producing a statistical report, you can share them by using the export feature. This allows you to export the charts as either graphics, so images, JPEGs, or as a table. Or for those of you who love Pro, you can even add these charts to your map layout. As we've seen today, we've cleared our dataset, and we've then completed it. And we've then conducted some spatial statistics to see the relationship between air pollution levels and mortality rates from preventable respiratory diseases. A stakeholder, for example, a council, may then want to use this data to run an initiative to reduce air pollution. Sometimes you might want to draw upon techniques from other analysis environments, and Ollie's going to show you how you can do this in Pro.
Thanks, Adriana. So we're aware that there are data science libraries that exist outside of ArcGIS. However, did you know that there are ways of bringing spatial data into both R and Python easily? For example, with the ArcGIS bridge, you can view and edit data in ArcGIS, bring that same data into R to perform detailed analysis using its numerous powerful data science tools, and then pass it back to ArcGIS to finish your maps. This is all working with the same geodatabases, hosted maps, images and feature layers, and this is all being done seamlessly without need for translation. The three functions in the ArcGIS binding package in R fall into three basic categories. Read and write functions that allow you to transfer your data between ArcGIS and R. Conversion and manipulation tools that allow you to format your data before analysis. And then finally, the wrapping tools. And these are really useful for when you want to wrap R and geoprocessing scripts, and it allows you to take a function and automate it or provide a self-service tool for colleagues. As well as option for R users, ArcGIS also has dedicated tools for those using Python. Within Pro, you are able to install and manage your packages using the package manager, which is essentially Conda integrated into ArcGIS Pro. You're then able to make use of Python using geoprocessing, automation, and scripting at the desktop level using the ArcGIS ArcPy tools, or you can do this at an enterprise level using the ArcGIS API for Python. Finally, ArcGIS Notebooks run spatial data science tools with which you can leverage hosted notebooks to answer questions, provide insights, and create visualizations. ArcGIS Notebooks include hundreds of Python libraries for when there isn't a need to run Python at the desktop level. Ultimately, all of these tools make it easier for GIS teams to work with data science colleagues, allowing for greater collaboration and greater data democratization across organizations. To conclude, spatial statistics can help you see your data in new ways. We've seen how we can draw on the available tools in ArcGIS to investigate the significance of spatial distributions, and how users can integrate powerful data science libraries from R and Python. So whether you're in the GIS camp, or you're more at home using R or Python, ArcGIS can provide you with the tools to access, integrate, and leverage powerful spatial statistics and empower you to tackle increasingly complex problems. There are now more reasons than ever to explore the world of spatial statistics using ArcGIS. Thank you for listening.